Welcome to Screencast 6.2. Our key idea here, we're going to talk about functions. We're going to talk about functions as equations today. So we need to know what a function rule is. And most of you already know this. A function rule is an equation that describes the relationship between inputs, which are the independent variables, and the outputs, which are the dependent variable. Okay, so what does this mean as an equation? Well, we're used to seeing an equation, maybe y equals 3x. So if I have an input or an x variable equaling -2, let's say that's -2, I'm going to put that in my x, and I'll show you right down here. Y equals 3 times -2. And guess what we get? We get an output, or a y that equals -6. And so that's what a function rule is. It describes the relationships between inputs, which are its independent variable x, and our output, the dependent variable y.
Good afternoon.
Okay, number one, writing function rules. So the first one, we want to write a rule for A for the output is 5 less than the input. Okay, so we have the words. And this I'm going to change the colors. So let's say the first one is blue. I hope I can remember this one. The output, it says the output. And then is another very important word. So let's do that in purple. Is. Oh, I'm sorry, I already did. Here we go. Is. Because is equal. And so I just immediately did that. And let's go to green. 5 less than, and here we have, let's see if this will work, the input. Oh yeah, yellow does show up. Okay, so let's make, those are the words. Let's make an equation now. So that's the words. Here's the equation that represents those words. Okay, so let's first look at the input. Now, the input is what variable? So the input is our dependent variable, and our dependent variable is the output, which is y. So the output y, and is always an equal sign, and then 5 less than. So the 5 less than, this one has to be changed a little bit. First we're going to say 5 less than the input. Well, the input If it's less than the input, then we have to put the input first, and the input is the independent variable, is the x variable, the independent. And now we're putting that it's 5 less than that, so that's minus 5. So a function rule for this is y equals x minus 5. And there you go, there's the rule. Example 2, evaluating a function. Let's see, let's ask what is the value of y equals 2x plus 5 when x equals 3. Now that's a good question. That's evaluating a function. Well, what do we do first? First we write the equation. So I'm going to write the equation y equals 2x plus 5. And then I'm going to substitute the input variable or the input value of 3. So here we go. I'm going to put y equals 2, and then I'm going to insert the 3, and then we're going to go ahead and add 5. And then all we have to do is simplify. 1, 2, 3. Simplify, and we have y equals 2 times 3 is 6 plus 5, or y equals 11. And that would be evaluating the equation y equals 2x plus 5. When x is 3, y is 11. We can always write it as an ordered pair, 3, 11. So there we go. The next example, oh, there isn't another example. So please do on your own numbers 1 through 4, and then come back for example number 3. Before we get into example 3, functions as tables and graphs, we just want to take a look at this. For the function x equals, for the function y equals x plus 2, y equals x plus 2. The input or the x values that anyone can insert or make up, this one they put in 1, 2, and 3. That's the independent variable. So you can put in any number, but sometimes it tells us what to put in. But right here in the table it's 1, 2, 3. When we put a 1 in, 1 plus 2, well, that equals 3. So y equals 3. So here we have 1, 3 as our ordered pair. And when we put a 2 in, we can put a 2 and substitute a 2 in. And when we put that 2 in here, 2 plus 2 is 4. Y equals 4. So when x is 2, y is 4 is the ordered pair. And then the last one, when we put an independent value in, we put a 3 in, the output is 5. So these outputs all depend on each of these inputs that we do. So they depend on those inputs. Now we can graph this line. We can plot the points. We go to 1, and then we go to 1, and then we go up to 3 and plot a point. We can go to 2 and go up to 4 and put the point, and so on. Go to 3 and 5 and a point, and then we can draw our line. Now all the solutions, every point on this line is a solution for y equals x plus 2. So by drawing a line through the points, you're graphing all the solutions of the function y equals x plus 2. So example 3, graphing a function. So let's graph y equals negative 2x plus 1. And we're going to use the inputs negative 1, 0, 1, 2. And we're going to make an input-output table. So what does that look like? Input, and that's our x variable. And then I'm going to put the negative 2x plus 1. We'll do our work there. Put the output variable, which is y. And then we're going to have our ordered pair here, our xy. Okay, so there's our table. So we're going to start with a negative 1. When we put in a negative 1, we must substitute that negative 1 into our equation. So I'm going to put negative 1 and then plus 1. So negative 2 times a negative 1 is a positive 2 plus 1, which is 2 plus 1 is 3. So our ordered pair here is negative 1, comma 3. The next one is 0. We're going to just put x is equal to 0, so we're going to substitute that in and put a 0 here, plus 1. Well, 0 times any number, 0 plus 1, would have to be a 1. So that's 0, comma 1. The next one we're going to do is, let's put 1. Let's put a 1 in there. We might have to make this longer. Okay, negative 2. Substitute a 1. And then add 1. That's the equation. So negative 2 times 1 is negative 2 plus 1. Well, negative 2 plus 1 would leave me a negative 1. So that ordered pair, let's make that uniform, is 1, comma, negative 1. That's our xy coordinate. The last number, let's put in a 2, and we'll say negative 2 times 2, and then plus 1. Well, a negative 2 times 2 is a negative 4, plus 1 is a negative 3. So our last coordinate is 2, comma, negative 3. So there we have our ordered pairs, and now let's go ahead and graph those ordered pairs. So let's graph negative 1, comma 3 first. We always start at the origin at 0, 0. So we're going to start there. We're going to go to the left to negative. Sorry. There we go. We're going to go to negative 1. And then up the y-axis, because this is our x and this is our y. Whoops. Our y. And then we're going to go up 3. So, and then we're going to put that point. So I can just erase this. Okay, there's our point at negative 1, comma 3. Now let's graph 0, comma 1. I start at the origin at 0, 0 and just go up 1. There we go. And the next one, 1, comma negative 1. We go to 1, we go down 1 to negative 1. This is all xy. X, comma, y. So it tells me where to go. Always starting at the origin, I go to 2, and then I go down to 3. And we can see it's a nice line that we have right here. So I'm going to just draw the line. Let's see if this works. Oh, yeah. Wow. First time. Beautiful. And so we could also then label our work. We can say this coordinate here is negative 1, comma 3, and this one is 0, comma 1. And this one over here is 1 comma negative 1. That's uniform. And then this one would be 1 comma negative 3. And there we have graphed our function y equals negative x plus 1. So that is graphing our function. Please do on your own right now numbers 5 through 7. 5 through 7. And when you're done with that, come on back. Okay, example for real life application. The number of pounds P of carbon dioxide produced by a car is 20 times the number of gallons G of gasoline used by a car. Write and graph a function that describes the relationship between G and P. So let's first do the words. The number of, and I'm just going to say, number of pounds, I'm going to abbreviate pounds, of carbon monoxide, carbon dioxide, okay, and then that is produced by a car is, which is, we know an equal sign is, and then we have 20 times the number of gallons of gas used. So how do we make an equation from that? Well, first we have to define our variables. I'm going to say P for pounds because that tells us P for pounds and G for gallons. So the amount, the pounds, P, is equals 20 times. So 20 times the number of gallons used, which is our G. So that would look just like that, the equation. P equals 20G. Now if we made an input-output table, we'd have G now is our input. Then we'd have 20G. Our output now is P, the pounds of carbon dioxide. And then we'd also have an ordered pair. I'm going to just say X comma Y. So if we put a 1 in, well, 20 times 1 is 20. So 1 comma 20. That is our ordered pair. Let's say it's 2. So 20, and I'm going to remember this is just substituting again. So that would be a 1, this would be a 2, and we're substituting that number in, and that would be a 40. So the next one would be 2 comma 40. Okay, and the last one, let's do one more, 20, and let's do times 3, because that's our G, our input value, and when we get out, we get a 60. So 3 comma 60. Now, we can go ahead and plot those points as well. So if we go ahead and plot those points, I'm just going to do a quick chart, graph, and this is our 0. I'm going to say it's going by, let's do by 20s. 20, 40, 60, 80. And these will go by ones. 1, 2, 3. And remember, these are the gallons and these are the pounds. So let's graph. My first coordinate, and I'll do a different color so you can see. Let's do, this is a pretty color. The first one I'm going to graph is 1 comma 20, which is about right there. Oh, right there. Very nice. The second one, 2 comma 40, which is about right here. And last 3 comma 60, which is about there. So now I get to draw my line again, and I'm going to do it from the origin and right out. And there you go. Remember, we have to put our, oops, that's not right. Let's go back to our pen, and there we go. our little arrow. So here we have the equation, P equals 20G. We created an input-output table, and then we also graphed it. So please do. Last thing is on your own, number 8, and we'll see you tomorrow in class. Remember that what functions represent. So we can do it as an input-output table, we can do it as a mapping diagram, and we can also do it by a graph. So there's 3 things, representations: input-output table, a mapping diagram, and a graph to show the coordinates of a function. Have a good night.